Good afternoon, everyone.
Often.
Right, press one if you're in front of a computer. Just now Noel already. Just now replied. Farah, thank you. Kelvin. Okay, Farah and Noel is in front of the computer already. Kelvin. Okay, it's not. Okay, Kelvin is also joined us already. Okay, thank you. Good afternoon, everyone. That's all right. Sometimes my keyboard also not as responsive I would like it to be. Right. Okay, so let's recap very quickly where we've been. Okay, so we studied OSPF. Okay, sharing of routing table between routers. Then we look at some network security concept or concerns. Yeah, and then we look at a further way to basically um, prevent traffic. Okay, or block traffic or allow traffic based on ACL, okay, access control list that is implemented on routers. Yeah. So you'll start to notice that a lot of our topics is wide area network. Yeah. OSPF is basically and here, okay, routing, static routing, and default routes. All these belong in the router configuration, OSPF, sharing of a routing table is a router as well. And then we look at network security concepts. Okay, so that's just introduced us to provide context for our next topic, which is ACL, right? So ACL also is implemented at the router, right? Router interface, right? And we continue that with chapter 5. Okay, so I hope you guys are doing your workbook, yeah, ACL workbook, right? And then this week we start with a new topic. It's called NAT for IPv4, right? So NAT is basically short for Network Address Translation, right? Okay, so if you recall, we've already a little bit about NAT before. Okay, again, this configuration is on the router itself also, right? And the reason being is because of IP version 4, lack of IP address, okay? Especially global IP address. Global IP address been depleted all over the regions in the world, okay? Right, so one solution they come up with is that for private networks, they give a range. I think 3 ranges for private networks, right? But even though private networks, there's a need for the hosts within the local network, private networks, to to connect with a service or server in the internet. That means outside of their local area network, right? So NAT is a way to um, to mitigate the lack of IPv4 address. So we don't get end-to-end communication. What we get is end to router communication, and then router will then map the IP address, the global IP address, with the host IP address within the private network. In that way, they can conserve IP address, right? So that's the topic for our lecture today, right? So start. I'll start to record as well, as usual. Right. So if you have any question, alert me and ask your question. Yeah. Okay. All right. So what are the topics we're going to look at? First of all, a little bit more about the description of the NAT, yeah, the NAT, yeah, Network Address Translation. That I've already briefly talked about, right? So explain the purpose and function of NAT. Right. So we haven't discussed about this yet. Types of NAT, and also the operation. You know how does NAT operates? Uh, Only in general we talk about it earlier on, and only in the context of why we need IP version 6. Okay, why why we cannot have end-to-end communication with IP version 4, right? And that is the context where we talk about NAT earlier on in fundamentals computer network, right? So here we dedicate a whole chapter to this topic, this NAT. So the second topic is the types of NAT, right? There are, I believe, three types of NAT, and all three of them have different ways of mapping private addresses to uh, global IP addresses, right? And they are each of them are useful in their own context, right? In context of large enterprise, uh, home type local area network, things like that, right? And then after that, we're going to look at advantages and disadvantages of NAT, right? So it's all not all disadvantages when it comes to NAT, right? There are some advantages as well, right? So just now we say types of NAT. We just introduced to you the type of NAT that is available. Then we go into more detail for each of them, right? So I said there's about three types of NAT, yeah. So static NAT, dynamic NAT, and PAT, right? And then after that, we further look ahead when we are implementing IP version 6, right? And because of the advantage of NAT, they don't get rid of it altogether, even though we transition to IP version 6. So NAT in a reduce kind of dependency on NAT, okay, is still there for IP version 6, which is called NAT64, right? So this is to provide the sort of advantages of NAT, okay, to carry over that advantages to IP version 6, right? So we hope that when we are now transition over to IP version 6, we still have that, but focus on the advantage of it, the usage of NAT, whereas we leave behind the disadvantages, right? Okay, so let's start with the NAT characteristics, right? So because NAT, the this functionality of NAT only come about because of the depletion of IP version 4 address space. So that's why we start with IP version 4 address space. All right. So let's talk about IP version 4. Networks, and we are talk about networks here. You talk about local area networks are commonly implemented using private IP version 4 addresses. Okay, as defined in RFC 1918. And it's shown here at the table here, the side, right? You can see the table. You have class A, B, C. So each classes, there is a range dedicated as a private addresses. What does it mean by private addresses? Means these addresses in these ranges are not usable outside of your LAN or your private network, right? That means on the internet, it is not usable. Okay, it will not be forwarded by routers beyond your own network. Okay, so private IP version 4 addresses cannot be routed over the internet and are wholly used within an organization or site, right? That means in your own local area network. Although we say organization or site, this includes our own private home LAN, right? Because nowadays everybody have access to internet, usually, mostly, right? And we all have our own wired or wireless LAN at home, right? Not only organization or site, uh, larger sites have used for local area networks. Okay, we also use it, right? Now the thing is, yes, we use IP version 4 inside our own organization, our own homes, But the more common reason why we actually have our own LAN is because we want to be able to access the internet. That means internet as an internetwork means it deals with wide area network. Therefore, right, due to the depletion of IP version 4, not everyone can have dedicated public IP version 4 address. Therefore, for all private networks will have their own private addresses. And since the traffic from inside your one LAN cannot be routed to a different LAN, okay, just using private address space. Therefore, it is okay to duplicate IP address within one LAN with another LAN and another LAN, another LAN, because they never meet each other because they are restricted to their own. These IP addresses, these private IP addresses are restricted to their own LAN only. Okay, but the thing is, you still need to communicate. The host inside the private network still need to communicate to the internet, to outside of their own LAN. Therefore, when your traffic needs to go outside of your own LAN, it needs a public IP address. The thing is, there's not enough public IP address. So what can we do? So that's where NAT comes in. NAT provides the translation between private addresses inside the LAN with public addresses that is used on the internet or outside in the wide area network. Okay. Now the thing is it can be directly one-to-one translation. Okay, means one private address is translated or mapped to one public IP address. Okay, but then that doesn't conserve the use of global or public IP address. That means the more common ones uh, will be a different type of mapping, where all the hosts inside the private network have to share. Okay, have to share. Maybe in the most extreme case, only one public IP address given by the ISP. So how does the router do this? Okay, so we know that there are three types of NAT. So we're going to look at all three types later, right? So you can see here, what is the primary use? Why is NAT invented? Is to conserve public IP version 4 address by mapping. Even if you have, let's say one-to-one mapping between private and public IP address is not feasible, then, well, if you have the resources or need to, that means you will have to talk to your ISP as an organization. Oh, I need arrange this many IP address, public IP address. Then maybe you can. Maybe they have that kind of product or service, right? But most probably for everyone else, especially for home network, then NAT is a mapping of many IP version 4 private address with maybe one or few um, public IP address. So NAT allows networks to use private IP version 4 addresses internally inside your own LAN. But when you need your traffic to go outside of your LAN, then NAT will translate them to the private addresses to public addresses that can be used outside of your own LAN. It can be used on the wide area network or the global internet. Right? So a NAT router, that means the NAT service is running inside that router, typically operates at the border of a stub network. So stub network means at the network, there's the end already. You cannot proceed further, right? Your local area network is the stub already. It ends there. Cannot, you don't have any more connectivity to other networks again. You're not like middle network, you're the end network. So that's the stub network. So normally, you can see here, this is what it means. Okay, the router that is at the border of your network will be will be installed with the NAT router. So when a device inside the stub here lah, okay, the stub network wants to communicate with the device which is outside. It needs to pass through this one, right? So you have this, okay, you have this one as well, but it's still within. If you think about it, this is your ISP perhaps. This router, and this router. This is house number A, house number B. Okay, access is provided to the internet is provided by your ISP. Maybe this is your ISP, right? So this is the whole thing is stuck. It's ISP. So your ISP is the one that's going to provide you access to global. So inside here, they still can control, right, private addresses. But once it needs to go outside onto the internet, it needs to go to this kind of router with the NAT service enabled. So the NAT will translate whatever private address space here with the public addresses, so that it can forward your packet, because the packet must have a global IP address, public IP address, and not private IP address. Or private address is not allowed to be routed outside. Okay. All right. Right. So if you have any questions or you want further explanation, please let me know. Let me raise up your hand. So under this one, how that works? So example lah. So R2 contain the NAT. So inside R2 there is a NAT table. What is inside the NAT table? It's the mapping between the source destination local IP address with the source destination for public IP addresses, private IP addresses, public IP addresses. So it's a mapping between the address that's used inside your LAN and the address that is seen by other hosts, okay, or other networks outside of your LAN. So here, PC1 wants to communicate with an outside web server. Outside here, from now on, just indicate as if it's outside of your own LAN. Okay, with public address 209.165.201.1. That is the outside web server address that you need to see. PC1 wants to communicate with an outside web server with public address, and that is the IP address. Of course, in practice, we type the URL. That's why we need the DNS server, okay, to translate the URL into the correct IP address, right? The entry must be there inside the DNS lah, or for it to be able to successfully, translate domain name against IP address. Right, so it wants to communicate. So PC1 sends a packet address to the web server, right? Then R2 receives the packet and reads the source IP version 4 address, okay, to determine if it needs translation. Of course, it needs translation. That is a local, that's private IP addresses. So if you want to access public IP addresses, sorry, this one, public IP addresses, then you need to use not this, but another public IP address. So we translate. So now the R2 translate this private to this public. So this become, once it reach R2, the packet sent by PC1 now, the source IP address will be replaced with that. Okay. All right. So there's no translation needed for because it's done by the server's own NAT lah, right, outside there. So this is server. They have their own router that might have their own mapping for themselves. But as far as R2 concerned, the outside local and outside global. Outside local means inside here. So there's this server, let's say it's web server, IP address within its own network. And then outside global means the IP address of this server that is visible outside by other hosts outside. Similar to here, inside local means inside the network. This is the IP address of this PC1. Inside global means here, the IP address that represent this one, this private one, you translate to this. That means this is now PC1 inside global. Okay, global means visible outside, so that you can see that it's a public IP address, right? So PC1 send the packet, reach here, receive the packet, reach the source IP address. Oh, okay, the one can need to be translated, right? So it adds an entry, which is the mapping of the local to global address. Okay. Then R2 will send that packet with the new source IP address, okay, to the destination. So when the web server receive the packet from PC1, it will see this IP address rather than that. See that. So when it replies, it will reply to this, right? And it gets sent to this router. The router checks, is there there's a mapping between this IP address? Yes, with this one inside local. So R2 will replace that and then send it off to the PC. Okay, because now it's inside, it will have its own, it will get back its inside local IP address. All right, so basically that's how NAT works. Okay, of course there are more refined mapping, because here the mapping is, all right, I have an IP address. So the question you will ask me is, hang on, if it's have its IP address, why don't you just IP address? Well, because inside we're going to use private. All private local area network will use, all local area network will use private. All right. So even if you do have, it's not like IP version 6. Even if you do have, let's say inside your own network, you have 10 hosts, and you have enough money to pay the ISP to get 10 global IP address, right? But necessarily, then you have 10 global IP address, you can straight away put global IP address in your computer. No. The situation with the IP version 4 is so crucial that they already adopted the system that all local area network will use private IP addresses, so you can't. So that means even if you do have, okay, the assignment must be done at the router with the NAT service, right? Just let you realize about this. Only when we go to IP version 6, then you are allowed to have that. You can configure a global accessible IP version 6 address directly to the host when you're on an IP version 6 protocol. Okay, let's look at NAT terminology, because it's confusing, right? Inside local, inside global, outside local, outside global, right? So 4 types of address: local, inside local, inside local, inside global, outside local, outside global. Right. So here's an explanation. I just tell you directly. You can read here later. Inside local means the private IP address assigned to your computer. You go to your NIC. Well, I assume that we are doing static configuration, right? We enter the IP address, but we know already it has to be private IP address. from the tree range. And typically home network or even lab network that we have in our campus here in Sabah, we use 192, right, /24 network, okay, for our private IP addresses range, right? Then we have inside global. Inside global is the IP address, public IP address that is assigned by the NAT to the to the host, host IP address that wants to communicate with the server outside. So when you reach R2, this one will be replaced by this, by R2, by the router. Right? Outside local is the IP address. We have no idea, right? We have no idea what it is because we can't see inside other organizations local area network. We cannot see. So that means we cannot see what's this for that server. So the outside local, which is supposed to be IP address inside the destination's network, is the same as the outside global, which is the global IP address represented by the router interface. Okay. Right. So inside local address, inside global address, outside global address, outside local address. When the packet reaches the other network, cross over the internet, reach the other network. Obviously, the NAT of the router for the destination server or host, whatever, right? Of course, there will be a translation done by their own NAT, but we cannot see it from our side, right? We cannot see from our side because it's hidden behind the router NAT. Does it translate? And when it translates, that packet is now inside the local network of the destination host, which you cannot see. Right? All right. So far, okay. Can I get your feedback on this? Kevin, okay?
Okay.
Okay. Peros, okay? Noel, okay?
Okay.
Okay. All right. Shall we continue? Yeah. All right. So next is the types of NAT. So there's not one single type of NAT. There's I think no cases. Case here we have 3. Right. So let's look at very briefly. Later we're gonna cover this in more detail in its own section. So the first one we know is static NAT or static NAT. Now this one is the one that doesn't really solve the depletion, and this is needed by large organization that absolutely need their host inside their network to have a fixed public IP address that is accessible outside of their network, because they're providing service inside the LAN. They want other people outside, in the internet, able to access their services, their servers. So it doesn't really solve the depletion. Sorry about my cough. Because the NAT in this situation uses the one-to-one mapping. One-to-one mapping. One local or private IP address is mapped to one global or public IP address. Okay, and it remain constant. What do you mean by constant? It means once it's mapped, and it's mapped because the network administrator is the one that provide the mapping, go inside the router, provide the mapping, and this mapping stays. That means no other internal host will be able to use that global IP address, because that global IP address, public IP address, already allocated to a particular host by the network administrator. So this one-to-one mapping, right, is taken. That means that global IP address, the public IP address, is taken by this particular host because it's configured by the network administrator, right? Again, why do we want to have that? Because we want absolutely that the service, the host that we provide this one-to-one mapping is a web server, okay, and then this web server, we want it to be accessible to outside, okay, to users or client outside of your own network, right? So we want to configure it this way if you have that requirement, right? And also useful if the device that you're providing a one-to-one mapping, one private to one public IP address, this mapping is fixed. Useful for device that must be accessible by, of course, authorized personnel. When offsite means when they are outside of your organization location. That means he does not, he is not part of the local area network, but he needs to access a service, okay, or one of the hosts when he is remote. He is outside of the um, the private network, right? Okay. All right. So static net requires that enough. This is the part where I say it's not actually alleviating any depletion of IP version 4. So yeah, static net requires enough public addresses available to satisfy the total number of simultaneous user sessions. So if 10 of your users from inside your private network needs to communicate outside, that means needs to access web server outside or whatever kind of host, then you must have 10 global IP address or public IP address to map to each of the hosts. So 10 needs 10, 15 needs 15. So you can see there's no there is no reduction of the need for IP version 4 addresses or the global one, right? But there is such a scenario, there is such a feature. So, all right, one-to-one mapping. Okay, there's nothing to stop you to use, I think, mixture, but static net is one of them. Then if we have static, we have dynamic. Dynamic means you don't have to provide one-to-one. If you have 10 hosts, you need to provide 10, no. Okay, if you have 10, maybe you have only 5 public IP address. So they take turn. And the 5 public available public IP addresses is called the pool. Okay, the pool of public addresses, right? So it's assigned to the host as they are trying to communicate outside of their LAN on the first come first serve basis, because not enough, right? Nice, there's not enough, right? So it's dynamic net means every time the host inside the network request to to communicate with a server outside, then only the net will allocate. Once finished, then the net is returned back. Well, the net will return back the assigned IP address back to the pool available for the next requirement or need from the host, right? So you can see there, when an inside device requests access to an outside network, dynamic net assigns an available. See, available. If not, no available, what happen? Have to wait. Have to wait until you get um, available global IP address, right? So basically, the net will look into its pool of public IP address if there is available, and net will allocate it to that host temporarily. Okay, until that host finish with communication, then the public IP address will be returned back to the pool, right? Nevertheless, no matter you are using it dynamic, you still need to, if you think about it, yeah, you still need to provide as many IP address, public IP address to as many clients, right? Client hosts that needs to communicate at the same time, communicate to outside servers or outside hosts, right? If don't have enough, then that means that client, that host in the local area network will have to wait. Wait here means cannot communicate, right? Still waiting for availability of global IP address. Okay, so both seems like yeah. Problem is we already said that our IPv4 address are depleted. Okay, this is not a good way to. There are cases where you need to do static or dynamic, depend on the requirements of the organization. But most of the time, we'll make do with this. In fact, almost all consumer-based internet access is based on this port address translation. This is the type of NAT, and it's also known as NAT overload. This is the one that we've been talking about in FCN. Yeah, we only have, let's say, think about your own ISP. Your ISP provide you only one single, I think it's from a pool also, from a available pool, a single public IP version for address, and this is made known to the NAT. But you still have many clients wants to connect outside. So what can NAT do? NAT, since there's only one global IP address, will have to do a different type of mapping. But all the hosts inside your local area network will be mapped to the same public IP address. Just that, how to differentiate? How will NAT know this host is the one that receiving these messages from outside? How do we map? Because now there's nothing unique. How to map? Your public IP address is the same for every host. Well, a way to differentiate is to attach the port number. Recall that the port number is needed by each host to identify the process that is making that sending that message outside. Okay, you cannot have a duplicate port in the same host, isn't it? Right. So basically, the mapping is this. You can differentiate between each IP, well, inside private address, inside local address, with the port number of the application, okay, from inside that host, right? So you can imagine something like this, lah, right? So inside local IP address is 192.168, and then the port number of the application. So that's the unique part, right? The unique part from coming from here, right? Now, this one, 192.168 is a different port, different IP address, but different port. But the thing is, the problem was this and this translate to the same global IP address, 209.165.226, isn't it? So how to differentiate between this and this? Well, we take the port number of the process that is sending this packet. So we add the port, the back, port at the back. So this is mapped to this. Because the reply to this, I know, ooh, okay, 133, it's 133, this one. Okay, now no longer are you going to use this inside the network to differentiate between hosts. You will use this stuff together. Since this always will be the same, so basically this one. Yeah.
Okay.
Okay. Thank you. Right. So let me see. Hmm. Okay. Mm, I think this one is different example because this is like 10, 11, 12, 13, 226, 226. I'm not sure where this is. Maybe this is another IP address. So I don't know why it's 7 is changing here. Because we are looking at TCP port number. This one is different. This one is different. So can map to that. Can map to that. Right. All right. So here, you can see Netstat. Type Netstat in your own command prompt, and you can see local address with a port, foreign address with a port. This is what we say socket lah kan, IP address but port number is a socket. Right. So PAT, further to PAT, yeah, PAT attempts to preserve the original source port. Original source port being the source port where the traffic comes from. Let's say here it's a port 80. Then it will try to preserve, right? But if the original source port is already used, because we only use the port to differentiate, what happens if two hosts is using the same application, so therefore the same port number. Now, please recall that this router here does not use the port number as your layer 4 use port numbers. Layer 4 use port numbers as a way to identify process. Okay, but when it reach R2, R2 doesn't care what is the process, because R2 is not concerned with what process is that port number. R2 is only concerned that that port number is unique enough so that I can map that port number to which address. Therefore, what happens if two local hosts use the same process and generate the same port number? And how do we differentiate? We can no longer, because it needs to be unique, right? The port number needs to be unique. So that's why next available port. If the original source port is already used, means already got an entry with the same port number usage, then PAT assigns the first available port number starting from the beginning of the appropriate port group. All right. So it's basically going to increment it lah. Right. Okay. So because it's only a way for it to map, so the port number, even if the NAT changes it by, getting the first available port number again, so that there's no duplicate. For example, like this lah, right? See, even IP address different, but port number the same. So when it comes to here, this one, if 1444 is two, cannot differentiate. So basically, the next available port number is after 1444 is 1445. Don't worry. Later, when it translate back to send back the the NAT service will be able to put back in the correct port. Okay, it's keeping track, so that because there's no 1445, It's supposed to be 1444 here. But if it's the destination is going to be, I mean, reply again back to what NAT will know. Oh, actually, I add this to make it so to translate back to this, it will correct back the port number back to the original port number, right? What happens if no more ports? Yeah, too many, right? Too many. So you try to get the next one, next one, next one. Right? There's none. Right? There's none. So I can't really too many. So I cannot go to there's no more port number available. No more port number available. So what does PAT do? PAT moves to the next address to try to allocate the original source port. Right? So the process continue for the port until exhaust all the ports. Right? Then move on to IP version 4 address, the address pool. Right? So that means it uses the next address. So if it's 226, and then no more, you cannot add more. So if there is an address 227 in the address pool, then automatically NAT will use the next address in the address pool. So again, we have to bring it to conclusion, right? If there's no more available ports or there's no more external IP version 4 address, that's it. Cannot, no, you have to wait. Cannot proceed, right? You have to wait. The host that is requesting have to wait. Okay, until one is available, either the port, the external available, or the port, the port number is available. Okay, I just want you to remember that the NAT in the router is using the port number as a unique identifier. It's not using it as its purpose in the host. In the host, the purpose of the port number is to identify, okay, the correct process, okay, inside the host, right? But the router just use it. The NAT inside the router just use it to be a unique identifier, so that it can map, right? You can use it as a mapping ID towards the local private IP address. All right, so let's compare NAT and PAT, right? So summary of the difference between NAT and PAT. NAT only modifies IP version 4 addresses because it does translation, right? So of course it modifies local private and global public. PAT modifies both IP version 4 address and port number, but PAT will try to work on the port number first. Only exhausted port number, then it will move on to IP version 4 address, right? So NAT achieves one-to-one mapping between inside local and inside global address. Okay, inside local, remember, it's a private IP address. Inside global means the global IP address as seen by other hosts in the wide area network. Whereas PAT, one inside global address can be mapped to many inside local address because it uses the port number of the application as a way to differentiate, right? So second point, NAT uses only IP version 4 addresses in translation process, whereas PAT uses IP version 4 addresses and TCP or UDP source port number, right? So for NAT, a unique inside global address is required for each inside host accessing the outside network. Okay. But PAT, a single unique inside global address can be shared by many inside hosts accessing the outside network. Right. So in terms of usage, you can predict, like you can imagine that NAT is used by large organization that can afford to have one IP to one public to one private, either static, the static method or dynamic method. But for a lot of us consumers, actually home users or home consumers, what we get is actually this PAT, right? Port address translation instead of network address translation, right? All right. So before we end this section, what about packets that do not use TCP or UDP? That means they don't have any port number. That's why the statement there. Some packets do not contain a layer 4 port number, such as the ICMP, which is used by your ping app, right? So it's just example, ping with its ICMP, but there are others. But we'll just look at example ICMP now, right? For ping. How is ping being handled by PAC since there's no port number? Well, this one is basically a fixed solution, right? Since ICMP do not use port number, what does it have? It has something called a query ID. Since that query ID is unique, then PAC will use for ICMP query ID of the ICMP query, right? In lieu of port number, because ICMP don't have port number. It's not TCP, it's not UDP. So PAT cannot use port number. Now PAT in terms of ICMP will use the ICMP query ID. It's a way to provide the unique identifier. Right? There are other ICMP version 4 message just that do not use query ID. Right? So they also don't use TCP or UDP numbers, right? And here we are just talking about ICMP, but there may be other protocols that do not use query ID, do not use port number. So how, right? How does PAT handles that? Now there's that one become detailed because there's no standard for each of them, meaning there is no standard as one particular number. So that means the solution is case by case basis, and it's beyond our syllabus. But if you do want to know, you can just go online and try to investigate on your own, right? Oh, what happens? What other, apart from SCMP, what other protocol do not use port number, and how does PAT handle that? Okay. All right. So okay, is it okay so far? Can I get some feedback?
Okay.
No question, huh? Okay, no question. All right, so no question. I will proceed to advantages and disadvantages of NAT. Right, so NAT provides these benefits here. Okay, so NAT conserve legally registered addressing scheme. Legally registered means the public IP address. In order for you to get public IP address, you have to go and request from your ISP. But where does the ISP get it from? From the IANA, right? The body in charge of IP addresses. And we know already, range of public IP addresses is actually provided by region, and then regional will provide by country, right? And country then divided into all the ISPs, or that's in charge of the providing access to the internet, like that, right? So those are legally registered, meaning you cannot simply say, oh, I want one IP, then I get on one IP, public IP, right? That's why. So that is depleting or already depleted. So NAT conserve whatever remaining public IP address. Okay, and by utilizing range of private addresses, IP addresses, therefore allowing privatization of intranets because it's your own network, local area network. Allowing privatization means you are free to use whatever private IP addresses because it doesn't matter. Net can translate your private IP addresses into global or public IP addresses for you. So that's a benefit, right? And then NET, otherwise known as port address translation or PAT, conserve more addresses by use of application port level multiplexing. So you can see here port level multiplexing is what exactly the under PAT, yeah, right? We're using the port number to differentiate between different hosts. Okay, when you only have a limited number of public IP address, then you cannot map one to one, right? So even you want to do dynamic one to few also cannot. So you use port number, provide the unique part of the mapping, right? So NAT increases the flexibility of connections to the public network. Well, because you have different NAT configuration for different needs, right? Static NAT, dynamic NAT, or PAT or PAT. NAT provides consistency for internal network addressing scheme. Because consistent because you're given a range. So when you're given a range, that means all network utilizing the same range will have the same kind of that means it's consistent, right? It's consistent. Whether I create a local network at home or I create it at lab or anywhere, I still use the same private address. There are three range, right? But still, if I choose one, then that private range doesn't change. So it's consistent, right? NET also allows existing private IP version 4's address scheme to remain while allowing for easy change to a new public addressing scheme. So that means what? This means no matter how you configure your IP addressing in your local area network, you do subnetting or you choose certain range or whatever, because it's translated, right? So it has no effect on the public addressing scheme. So let's say your ISP change your public IP, and actually that is the common thing because your public IP address given by your ISP is from a pool. Unless you want to pay extra, you want to get a static IP address. This is the static NAT. I'm not sure how much telecom is, no, Unify or TMNet is charging monthly for the privilege to use static IP, right? But they do have that service, that price, okay? But no matter what, even if you keep changing your global IP address, it has no effect on the vice versa also, has no effect on the choice of IP addresses or IP addressing scheme that you use inside your private network because NAT is the translator. No matter what, it knows how to translate, right? So, from security point of view, NAT hides the IP version 4 addresses of users and other device because private IP addresses will not be forwarded by the router. And it's stopped there. So if you want to talk outside, you have to use the inside global IP address. So the NAT hides the IP version 4 addresses that you use inside your private network. This is considered good because it's enhanced your security, right? Because whenever someone wants to send a message to a particular host they never know which IP address is it, because it's maybe allocated by NAT, translated by NAT, and keep changing. It's dynamic, right? So make it very hard for outside the network, your network, to attack your system or to find out about your system, because it cannot connect, because it doesn't have access to the private IP address, only the inside global IP address. Right. So let's look at disadvantage. Well, because it has to be processed again, we have already so many intermediate devices to process whatever, right? We've learned so far already SCL, we got ACL. They talk about switch, right? Switch introduces its own latency, but routers, not only you have to do the routing table, you have to do the SCL, you have to do this one, NAT, right? And if you configure DNS, also have DNS or DHCP or Slack for IP version 6. You see, the thing is, all these processes increases forwarding delays, increases latency, right? End-to-end addressing is lost. Of course, there is no such thing. No such thing end-to-end addressing in a IP version 4 networks, because it's only end-to-end to each other's router with NAT. Okay, end-to-end IP version 4 traceability is lost. So yeah, you cannot trace who you're replying. If you have a web server and a request come in, the only thing you can say is that request comes from a specific IP address from the organization. You cannot pinpoint which PC, which host inside the organization send the request. The only person who can know is actually the network administrator for that private network. And if there is a log, okay, log of the net table update, right? So end-to-end IP version 4 traceability is lost. Cannot trace already. Cannot trace like as if you trace the packet. In packet tracer, you use the simulator mode. You can trace, oh, this packet goes to here, goes to here, goes to here. You cannot do that on the real network because of the translation. If you don't have access to the translation table, then you cannot know which host in the private network actually send the request or receive the reply. Right? Traceability is lost. NAT complicates the use of tunneling protocols. So what is that NAT does? NAT want to change the inside or change the source and the source IP address, right? So the thing is, if you use tunneling means encrypted, right? It's encrypted. That means the original packet is encrypted and stored inside another, encapsulated inside another packet with a tunneling protocol. Okay, if it's encrypted, then how net going to open it up and check inside to replace the source IP address, because performing the mapping, right? Want to change, so it become complicated for for this kind of scenario, right? Services that require the initiation of TCP connection. This one is the three-way handshake. Whenever you want to create a TCP connection, so services that require initiation of TCP connection from outside network or stateless protocols such as those using UDP can be disrupted, right? Due to the translation, the IP, how this like the port numbers, right? Okay, right. So that is basically a brief overview of NAT. Okay, and then we go to in more detail. We start with static. Static NAT is one-to-one mapping, one private, one public. Okay, one private, which is inside, and one public, which is outside. So one to one. So if you have 10 computers, then you might as well have, and if you want to allow the 10 hosts in your local area network to have access to the internet, therefore you have to get ready 10 global or public IP address. Because one-to-one mapping, right? So static net allows external device outside of your network to initiate connection to internal device using statically assigned public address. Because you map, so that public IP address belongs to that particular host already. So if that means you can publish it, then outside internet, when you see that, that IP address, global IP address, because it stands for what, let's say web server, then you can then link that IP address to a domain name and then register it inside DNS server. Since it's not changing, because it's one-to-one mapping, not changing anymore, then that's valid until you revoke the domain name IP binding. Yeah, this is what it means, right? Of course, client outside will not remember your IP address. Normally, you will do the entry into a DNS server. Okay, IP address static one, right? That doesn't change with the domain name. So later, anybody wants to access your web server, just type in domain name. The browser will check the DNS, return back the IP address. But once it reaches the router, okay, it's a straightforward one-to-one mapping, right? So the router just look, oh, it's for this, you know, it's for this local IP address for this particular web server. All right. Is it okay? This configuration one-to-one mapping.
Okay.
Yeah. All right. Okay. So if you're asking, hey, why if like that? Why not just give it the public IP address rather than because it doesn't work that way already. We don't do that because the local area network doesn't use public IP address, right? So it has to be assigned at the NAT at the router, the border router. IP version 6, yes. IP version 6, yes. You don't want to use the NAT, you can use direct end-to-end connectivity. But since NAT came into being, then all local area network will use private IP address already. Cannot use the global IP address or public IP address. All right. So how do we configure static NAT? Two basic tasks when configuring static NAT translation. This is in your router. Step 1, create a mapping between inside local and inside global address. And the command is IPNet inside source static. Right? Static means you configure your server manually and then provide the mapping, mapping. So IPNet inside source static 192, the inside local, and then inside global. All right. And then the inside interface means IP address. Give it the IP address, IPNet inside, and exit. Then go to the serial. This serial is facing the internet part, the global part, the public part. Then IP address 209.165 and so on. IPNet outside means this is the this is the inside global configuration. This is the inside local configuration. Means this one going into the switch connecting to this address. right? Hang on. I think I say wrongly this one. This one is not the same address. 192.168.10.254, not the same as 192.168.1.2. Let me just check. Is it this one? 10.254. I think this one is the same. So yeah, is this inside? Is it inside global? S11. Yeah. This is inside local. Yeah. Inside local. But inside local 192.168.1.2, and this one belongs. Means there's another route. Can we have been another router? It's not the same. It's not the same address. Can you guys see that? Not the same address, right? Because of this,
Oh,
this one is not this. That means we have another our own network this side. Networks plural, right? So that's why this one is different different IP address compared to this one. This IP address. So it means it works even with multiple networks. The serial here pointing to here, maybe there's another router here. So that link itself is this address 192.168.1.0/24. Whereas the network that contain this IP address for that particular host is 192.168.10.0 network. Okay. Right. So that means the server belong to that network, whereas there's another network here. That means here cloud only hiding all the necessary like routers. Okay, they not necessarily one network here. That's what I get from this configuration, right? Okay, I think it's still the same. Yeah, just this one telling us from this web server to this client, and this client is accessing the web server, right? Okay. All right.
okay.
So this cloud hides the a lot of things lah, right? Like additional routers and so on. Okay, analyze static NAT. So here we're going to trace step by step. Okay, how does the NAT static NAT works, right? So here the example is between client and the web server, and I believe the configuration earlier on. The client sends a packet, this one, number one, to the web server, to this, right? R2 receive the packet, okay, from the client on its NAT outside interface, this one, and checks its NAT table. R2 translate inside global address of to the inside local address and forwards the packet towards the web server. The web server receives the packet, responds to the client using its inside local, this one. R2 will receive that packet and will translate. Remember static translation. Translate that to the inside global address, which is this one. Okay. And then what the client says is this the address of this web server here. Okay. So the client, that means we are actually bypassing one process lah. Okay. The client, of course, doesn't type this. Client types the URL, but the URL gets translated by the DNS server. The DNS server translate the URL to this, the domain name to this, right? So you bet that whenever you see the IP address, it's not necessarily the IP address of the individual server. It's hidden by the net. So when you say Google server's IP address, okay, definitely you are looking at the inside global address of the Google server. Okay, and that is also simplistic because Google server is distributed. There are many Google server. A redirection is done to basically to load balancing. What everyone see is the inside global address of Google server, but inside their local area network and with a plural S and can be all over the world, all over the world, will be many web server providing those such engine, for example, and each of them have their own inside local address translated by NAT. But the face that you see is one single IP address of Google server, which is if you're not familiar with network, you think, oh, one server only mapped to one, right? It's not. The net can provide the translation, and the translation even more sophisticated because it's not only one web server that Google has, and it's distributed across the globe because the data center is across the globe. Okay, just let me just check what is this messaging. Okay, all right. So it's something else. All right. Is that okay on this part? I really need to know that you guys understood.
Hmm,
Okay.
so far, okay.
So far, okay. So now you know how does Google IP address is hiding the multitudes of Google web server. That's how they can distribute. They actually hide. That means their translation, the net translation, not only to one web server. They in fact, I think for more sophisticated, they can load balance the. So that means they can redirect depending on the load of a particular data center where there are many worker computers, then they can redirect it to a different place. Of course, the closest they will try to give you the closest one because of latency. Okay, that's why if you're closest to the Singapore Google web engine web server, then they will send it to you to Singapore because it's shorter distance, right? So yeah, okay. Anyway, one IP address hides the what's inside you cannot see. So that means the IP address for Google is actually the inside global address. All right, so let me just continue. To verify, that one was just a configuration, right? So to verify static NAT, you type this in the privilege mode. Show IP NAT translations. Then it shows you again the inside global, inside local. Okay. So if there was no communication that time, they can only show you inside global, inside local. If you issue the command while there is an ongoing, okay, you issue this command at the router again. If there's an ongoing communication happening, then you will see this also outside local and outside global. Okay. because translation is just being done, so you can actually see it. All right. Right. So another command that is useful for you will be show IP NAT statistics. Right. Okay. So display information about, because the statistic, it shows you how many times something happened. Right. So that means in this case, what is the active translation? Right. So what are the parameters? Number of addresses in the pool. If you're using pool, like that means you have a certain number of addresses to be mapped, shows you that, and then number of addresses that have been allocated. You can see there. One static, when there's one mapping, okay, one-to-one mapping. Zero dynamic. Dynamic here is the pool. Okay, you basically only allocate when it's needed, just like the DHCP or dynamic, right? But this one is to allocate the global, inside global IP address to the inside local IP address, right? So if you want to clear the statistic, type clear IP NAT statistics. Very helpful for if you want to test, so you don't want the previous logs to uh, to be populated here. You because you want to test, or you want to test, you start with, you reset everything so that you can see. Right. So next we look at dynamic NAT. Here there's a one-to-one mapping, but we have limited number of IP local global. Sorry, IP global. Right. Just now the static, you have one-to-one means if you have 10 hosts, all 10 hosts want to access the internet, then you will have 10 um, IP global. Now the thing is, sometimes you don't have to provide all 10, because remember, you basically want to provide one-to-one mapping if that is a service you want to provide to your outside client, right? So maybe you just do a one-to-one static mapping for servers, right? Web servers facility. Okay. The rest we provide using dynamic, right? So dynamic NAT will map automatically inside local to inside global, right? So that means you have a pool of inside global addresses. Okay. So whoever requests first, they get, right? So if the pool is exhausted, no more available for now, right? Let's say, then the host that requests, to use services outside of the local network will have to wait. You can see there, will have to wait until one of the hosts finish communication, then it let go of the mapping, and then it return back to the inside global IP address is returned back to the pool of available, then only can be allocated. If not, then have to wait. Right? Now, so that's all the difference between dynamic and static. So let's see how to configure dynamic NAT. Right? So 5 tasks. Define the pool of addresses first. So you can see the first command is IPNet pool, net pool 1, give the name, and then 201.65, 200, 226, 200, 165, 200, 240. So 240 up to 2009. And the mask is your subnet mask, right? And the second is the ACL. Okay, the ACL that you configured. So you can see configure standard ACL to identify, which is to permit. Identify means matching this. Okay, and then permit only those addresses that are to be translated. So which address that is going to be translated, that means you can control which address can go outside. then bind the ACL to the pool, this pool, using IPNet inside source list is this one. That means once you set this, only this matching, IP address matching this will be allocated with the dynamic IP address. All right, so far, we say 5 tasks, we only reached 3. So the next, identify which interfaces are inside, right? So then once you identify, so it's facing the inside, right? Interface serial and then IPNet inside. Then step 5 is the outside. So interface serial 11 configure as IPNet outside. And that's it. Right? That's the configuration. 5 tasks only. All right. So dynamic NAT translation process. This again similar to the static NAT, but we're going to look at dynamic NAT. I think it's almost the same, except that the pool of IP address is limited. Right? PC1 and PC2 send packet requesting a connection to this server. So they are inside this. So this is the border. So this is the one translating. So R2 receives the first packet from PC1, checks the ALC to determine the packet, the access list control, right? Or ACL, not ALC. Sorry, you guys can check to replace this. I think this is ACL, access control list, not access list control. Check the ACL to determine that the packet should be translated. Select an available global address from its pool, and then creates a translation entry in the NAT table, which is this one. Okay, this is the inside global address available in the pool. So 10, 10, 10, right? 10, 10 map to this, right? Right? So the second entry is if the PC2 sends a packet to access the server here, then R2 will check, is this belong to the ACL? Yes, permit the translation, okay. So provide the mapping. If there's an available inside global address, then it will provide the mapping, right? So 1110 map to 200.227. Okay, then communication can occur between the two clients with the server, right? So the server receive packet from PC1 and respond using the inside global address just now. Server receive the packet from PC2, again using the inside global address that's provided by the NAT. When R2 receives the packet with destination of 226, it will map again. Oh, who is that? 1010. Then it forwards to 1010. If the server, the router 2 NAT receive and checks the destination is 227, it goes to this mapping. 227 belongs to who? 1110. Forwards it. Change it. Change it from this to this and forwards it to this one. Right? R1 will understand this one already because they are inside here. Okay? Of course, R1 can forward here, from here to here, whatever. This is cloud already. These are all inside network already. And then once when it's delivered to PC1 and PC2, right, they will continue back and forth. And the same process just now will repeat. Okay? Is that okay? Is my explanation sufficient, you guys? I need some feedback.
Okay.
Okay. All right. Calvin?
Okay. Is there a limit to how many dynamic is like two? Is there a limit 228, 229? Is there a limit?
A limit, yeah. The limit is the range of address that you are given by SPLO. because the global, remember, this global IP address, you cannot simply use. You have to ask from whoever the in charge in your own country. Yeah? Usually the ISP are given it, right, from IANA. So every region is given a range. Then it's divided into countries, and each country get a range, and then divided into to all the ISPs. Then if you're a business and you want it, then you have to pay. Then depend how many you want, right? How many IP address you want, and then that's the range. Okay, if you're talking about the address range for the particular address range, then yes, the limit is, if you can afford, even if you can afford it, if you can afford it, then the whole range you can request from ISP if it's available, right? But it depends lah, the ISP, how many they will give to you, how many is available. It all depends on the ISP after that. Yeah. I'm not sure about the actual business. How is the, because I never been in a situation where I have to go to the ISP and request all this global IP address, right? I assume there's a product, right? There's a business product that you can ask, because even for normal consumers like us, I think we can only ask for one, right? And monthly you pay for that one static IP. But if you ask more than one, I think that is a business product. So then you have to deal with the ISP of your choice. They say Telecom or TMNet or Unify or whatever lah, for business product, different from normal consumer. Then you have to see what service or product they have, and then pay accordingly, and then you get how many you want lah, if there's available. And the limit is actually set by the ISP lah. I don't think you can pajak everything. Okay, let's say you're very rich, your company, and you want to pajak all the I don't think can also. ISP is going to the limitation of how many the IP address that you can have is, if you technical say, I don't think so there's any limit lah, as long as it's within the range. Yeah, but when it comes to real world, then again depend on the ISP. What is their policy? How many can a single company get or request for? Does that answer your question, Kelvin?
Yeah, sir. Thanks.
Yeah, you can maybe if you
usually how many the range?
That 209.165 200
until 255.
Is it a look at the class? 209 is what class? Is what slash is that? Slash something. Yeah, you need to know the slash something, and then you know the range.
Depending on okay.
Can remember the slash, because I was thinking about class easier. You can see what class, but then I realized a classful is no longer used. So classless we have to depend on the slash. So since this one is given as an IP address already, we don't see the prefix at the back, so we can't give you the range. It depends on the slash prefix, the classless, right? So that is the I would say the technical range lah, or technical limit. Once you know the slash prefix, then you know what is the range of your IP address inside. Then that is basically technical limit. But then there is a procedural limit, the limit of the ISP punya policy. It means per company, per organization, how many can I sell, rent to you? Rent, this one, right? Yeah. How many can I provide to you? Right? And how much is each lot? This one, I haven't seen that service. I think it's maybe hidden somewhere in the business, because I normally see they only talk about the bandwidth provision, whether it's shared or it's this line, but never talk about the IP address. Maybe I didn't scrutinize in detail. But you guys, especially Kelvin, you are interested, right? You can just go to the see whether if you go to Telecom or Unify or TMNet, see their service on the business side and try to see whether they have such product like these IP addresses. Okay, but definitely the ISP themselves have this lah. They can use as many because they purchase it, right? They purchase it in bulk. So and then they will divide bagi for all the businesses and also normal consumers in the Malaysia lah. Let's say we talk about Malaysia, right? Okay, that's the best I can give you because I'm not sure about the business part, Kelvin. So maybe you can find out and then update us later on.
Oh, okay. Thank you, sir.
Yeah, maybe you try to find out because it's curious also. Yeah, limitation in terms of procedure. We know the limitation for technical, as described earlier on, but whether we can actually fulfill the whole range or not, again, that's depend on policy. Yeah, policy of the ISP. Right. So okay. So we analyzed dynamic NAT. So we want to verify dynamic NAT now. Okay. Show IP NAT translation. Again, you see inside global, inside local. It's not much different from static NAT, actually. Right. And then put verbose means this one is quite lean. It just give you inside global, inside local, outside local, outside global. It's empty here because I think there's no communication ongoing. And then if you want more info, you put verbose. Okay. Then it tells you additional entry lah. I mean additional info. When was this entry created and used? Okay, because when it's created means because it's first come first serve. Okay, and so that means if the pool still available IP address, then it will map it, and then that means you can then see the creation and how long it was used. Okay. Right. So by default, transaction entries time out after 24 hours. Right, but you can adjust this lah. Okay, 24 hours is default. You can set your own timeout. Okay, in seconds. And so that means you want to, because maybe you don't really have many, so you want to reduce it a bit, right? If you don't use it, and then straight away, because you have more users than you have. But if you confidently that your pool is large enough, right, for the number of users you have, then you can leave it at default 24 hours. After 24 hours, the mapping, the entry will be deleted. Then if you want to connect, you will be reassigned again. That is if there's available IP global inside the pool. Right? So if you want to remove entries forcefully, you have to type clear IP NAT translation. And then it will clear out the NAT table for you, NAT entries. Okay. Then you want to see statistic, and then let's just type show IP NAT statistic, tell you total number of active translation ongoing, NAT configuration parameters, number of addresses in the pool currently. Let's see, where's the pool? Yeah, so you can see here the pool, NAT pool 1, start. Okay, allocated is 2. Total address is 15. Allocated 2 means you still have 13. Right? Right? And show running config shows you then you have to filter include NAT, right? And it shows you the configuration for your ACL, okay, in terms of the NAT. Okay, the NAT pool is given here. The NAT mask is the basically the prefix, right? and then the ACL, right? So that means source list one, that means ACL number one. So that means if you then you use the normal command to see the ACL, to see the entry for the ACL. All right. So okay, so PAT is using the port number. So I'm gonna stop here first, you guys, to give you guys a quick break before we continue on PAT, right? And we have to finish on this chapter before we can actually do the tutorial. So we'll continue the last. I think this one is the, if I'm not mistaken, this is the last, yeah, penultimate section after PAT, then NAT64. Then we finish um, this chapter. Right, before we continue, I'll give you a break. Is 10 minutes okay for you guys? 10 minutes break?
Okay.
Okay.
Okay. All right. So we'll resume after 10 minutes, about 2:10. Hello everyone, welcome back.
Hello.
All right.
Hello. Also,
Right. Okay, so everyone back here. All right, so we'll continue. Okay, so this second last penultimate lah, right? Section is for port address translation. Okay, differs in the name also, and also how the mapping is being done. All right, so let's have a look on PAT. Right, configure path to use a single IPv4 address. Now, this scenario is more akin to the scenario that we all, the normal, not business consumers, the normal consumers of an ISP, right? Because ISP have to cover the requirements for the whole population of the entire country. Perhaps if the ISP is serving the entire country, for example, our telecom, the TMNet and the Unify, they basically their consumers are the entire people, uh, normal consumers, right, and business. So the thing is, we all know that the problem with IPv4 is the depletion of the public IP address. So this port address translation, okay, is a modification of the NAT, right? In the sense that we because we only have one inside global address, so we don't have the luxury of static mapping. We don't have the luxury of dynamic mapping, because dynamic mapping entails that you have more than one IP address. That means a pool of IP addresses. These are all public IP addresses that you can get from the ISP. But typically for normal consumer, right, you actually got dynamic that is from a pool that is given by ISP. But if you get a static one, right, you also get both static and dynamic. You only get a single IPv4 address, right? So problem with that is that inside your private network, you might have more than one device, more than one host. So each host will need to connect to a server remotely, go to global, yeah, the internet. So how does the net still perform the mapping when the net only has a single IP global address, right? So this is the topic we are looking at, right? And from the name itself gives you a clue. It says P stands for port. Port, that is same as port number of a process or application that is running in a particular host, right? Since all communication, right, apart from a few like they use other protocol like ICMP, most application uses TCP or UDP, right? Therefore, we'll have a unique port number allocated to each of them, each of the process. This is a way to uniquely identify a particular process in a particular host, right? So in the PET process, PET uses this unique ID for process inside a specific host as a way to differentiate between different hosts, okay, that uses the same single IPv4 address. Okay, so the way you configure is you see, yeah, where you configure is this part. So IPNet inside source list one basically the SCL number one interface serial and overload. The overload here is the keyword that tells NAT to use port numbers, right? And then here's the SCL permit, and then the range of addresses that is allowed to access to access the net, right? And then we say what is the IP net inside, which is the 010 here, and then the other interface that's facing the internet is the IP net outside. So this is basically the only thing that you need to put differently, right? An ISP may allocate more than one public IP version 4 address to an organization, right? In this scenario, the organization can configure PAT to use a pool of IP version 4 public addresses. So you can still use PAT even if you have a pool, right? So to configure PAT for dynamic NAT address pool, simply add keyword overload, right? So all the same, except this one, you can still use pool, right? The mapping now, that means here, why you have pool? Because if you exhaust the next available port number, then it will use the next available IP address from the pool. If you don't have, the thing is, for home consumer, no matter we say that we have many hosts, but our number of hosts in our private address, private network at home is never going to exhaust the port number, right? So we even if we have only one address, there's no problem. But in an organization, right, they may have more. Their network might be larger, so they may exhaust the port number. Then they will use the next available IP address in the IP address pool, right? So the only difference here is that keyword overload to tell NAT to use PAT, which is address using using port number. Okay. Right. So here is an example. We trace or we analyze port address translation from server to PC. Server being this side, PC being this side, and R2 being where our NAT is. Okay, where our PAT is. All right, PC1 and PC2 send packets to server 1 and server 2. Okay, that's the intention. The packet from PC1 reaches R2 first. R2 modify the source IP version 4 address to the inside global 209.165.200.225. Right? Then the packet is then forwarded to a server 1. Okay. The packet from PC2, this is the second packet from PC2, different network address, arrives at P2, R2 PAT changes the source IP version 4 address of PC2 to the inside global. It's the same, 209.165.200.225. So PC2 has the same source port number as translation for PC1. PAT increments the source port, right, number until it's a unique value in its table. In this instance, 1445. Okay, so you can see here, right? This one is 1010, this one 1010. The port number is 1444. Since it's overload, then gonna use the port number. Okay, since the first this packet from PC1 is arrived at R2 first, then we just use 144 as our mapping and forward it. Then the second packet comes from PC2. Okay, also using the same software. So the port number is the same, 1444, but 1444 matches with the inside global address, means there's a conflict. How do I differentiate between the first one and the second one? Therefore, we increase to the next available port number, 144 plus 1, 1445. Remember, the reply, when the reply comes back, R2 must change back that one, or else there's no such thing as 1445 at PC2. It's also 1444. But for the purpose of being a unique mapping, then R2 actually increased 1444 to 1445. Okay, and send it over to PC2. It will return back as 1445 also for the right, because this is source. Source, when you return back, becomes destination, so it's never changed by the client. Sorry, the server. Right? So far so good. So far okay.
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 Right. All right. So okay. So we proceed. I think here. I just want to see. Oh yeah. Server to PC, PC to server. So basically, this is a return value. This return, yeah, arrive at R2. So you can see that this is what I meant. The 1445, there's no such thing, but the R2 remembers that it has actually increased that one just to make the mapping for this particular communication unique. So it will restore it back to 1444 once it add the inside local address. So when it reach the inside local address, the PC2, yeah, PC2 11 there. I'm not sure why this one is 16810. If we are using this PC1 and PC2, I think this should be 1110. Can you guys see that?
Yeah, maybe typo.
So with 1010 and 10, 1010, 1010, 1110, 1110. Because it's PC2, ma. Cannot be that the address changed. Let me see. Yeah, the error stopped from here. Okay, detected the error. Here, look, 1010, 1010, 1110, 1010 cannot be 1011 because PC2, because they are different networks. So it's a typo, right? Take note, please. So later when you are doing revision, you see the typo. PC1 belong to different network from PC2 because of this, the router interface. You can see that. So the topology is correct, 1010, 1110. But here it suddenly become 1010, 1011 means these are the same network, cannot be, right? You see, PC2, 192.6.10.11. It should be 10, 11.10. Should be this one. Can you guys make a note for this? Right, take note.
Okay.
All right. Okay. So it doesn't change our conversation. Our conversation is that when the packet was going to server 2, because 144 and the inside global, they are the same, cannot differentiate. So what TAP did is to increase the port to the next available 1444 to 1445. That is the source port, right? So when the source port reach here, this server will send back without touching that become the destination port. But R2 knows it's changed that. So when it comes here, when inside local is inserted to replace inside global, then the port also adjusted back to get back the original port number. So that when it's sent back to PC2, PC2 knows, oh, it's 1444. Because there was no such thing as 1445, yeah? That was just done by R2 to differentiate between these two mapping. Okay? Right. So same, still the basically I summarized the information just now. I summarized all the explanation here. Okay. All right. To verify PAT, you can use this command. Okay, so we've seen it before. Show IP NAT translation. Then it shows you inside global, inside local, outside global. Now with addition of these two. So this is inside global. Notice it's 5 compared to this. Here you can still tell it from just 10, 10, 11, 10. So no matter the same port, it's okay. But once it's inside global, because only one IP, public IP address. So these two are the same. So if these two also the same, there's no way to differentiate, right? So the next step the PEP does is increment that to get the next available port number 1445, right? And send, and then when it receive, it will convert back the inside global to inside local, then convert back the port that is added with 1, incremented by 1 back to the original port. Then delivery will be complete. Right, so verifying path, show IP NAT statistics. So you can see 2 dynamic, right? 2 extended. This extended is the overload lah, right? And then shows you some information also, the starting, the ending, the net pool, all the very similar information lah from before, the statistics. All right, so that's about it for port address translation. Right, so our final topic is NAT64. NAT64 is the IB version 6 version of the NAT. Now, NAT specifically for IP version 4 is to alleviate the problem of depletion of IP version 4 public addresses. But IP version 6 solved that, right? IP version 6 is introduced to solve that thing. So we should not have any more problem with depletion. But remember, there's advantage of NAT, and one of it is the to provide to hide your local private network from outside eyes. Right? You don't want, even if you are direct end to end, you don't want people to be able to see inside your private network. Now it's private, it's privacy, not private as in because you're using a private IP address, right? So you can see IP version 6 was developed with intention of making NAT, which is used for IP version 4, right, unnecessary, because IP version 6 is 128-bit compared to IP version 4 is 32-bit. So this one, more than enough to cater several times over, to cater for unique IP address. So NAT is no longer necessary if you talk about that purpose, right? But IP version 6, if you notice, right? If you notice the types of IP version 6 unicast address, it includes private address space, right? And unique local addresses. Okay, so IP version 6 unique local addresses similar to private addresses for IP version 4, but it's not intention of this anymore. It has a different purpose. Okay, so you want ULA addresses, which is private addresses, to allow local communication, which means if you use private addresses, it will not be forwarded outside of your own local area network. Right? So ULA addresses are not meant to provide additional IP version 6 address space because there's no need, nor to provide a level of security. Okay? But it's just for convenience, local communication within your own site. Yeah, especially if you don't don't intend to go online. But if we do, then there is a NAT64, right? That allows translation, protocol translation between IPv4 and IPv6, right? So even though you do have Oracle address, it does not need to be translated because IPv6, if you look at the unicast address, they have more than one. That means you can set more than one IPv6 address for each NIC. One of them is ULA, or unique local address. You can also specify the global IP address, which means there's no need to translate. But the translation done by NAT64 is protocol translation between IPv4 and IPv6. So you can see NAT for IPv6 is different context compared to NAT for IPv4. Varieties of NAT for IPv6 are used to transparently provide access between IPv6 only and IPv4 only networks. So remember the transition between IPv4 to IPv6, and one of you have those stack, what we normally have, but you also have the translation, right? And that's done by NAT64, right? So it's not private IPv6 to global IPv6 translation, because that is the idea we have for IPv4. But it's actually for translation between IPv6 to IPv4, because we are in the transition process, right? So NAT for IPv6 should not be used as long-term strategy. It's only used because we are now transitioning from IPv4 to IPv6. Once we fully transition, there's no need for NAT64 anymore, because we should be using all IPv6. Okay, this is only needed during transition period, where now we have combination of IPv4 and IPv6, right? Okay, so any question on that?
No.
No, huh? All right. So yeah, so that brings us to the end of our chapter, right? So please read the what did I learn in this module. It's a long list. I'm not going to go through it. Okay. So this is basically summarize what we have learned in this chapter, right? So in basically what is NAT for IPv4, and then we learn three types: static, dynamic, and PAT, or protocol. Port address translation. And then finally we learned that there is such a thing as NAT64 for IPv6, but it's actually to translate between IPv4 and IPv6 to help the transition. Okay, to help the transition. Okay, so we've done with this chapter. Okay, so I'm going to stop first the recording. All right. So now if you look at our tutorial, we actually continue with tutorial 4. So tutorial 4 is already shared with you guys from last week. So please continue, excuse me, to do the tutorial 4, and some of it is actually from the workbook I've also shared with you guys. Is that okay, everyone?
So can Asa?
Can.
About the NAT, right? It's about assigning the private network to a public network, right? So how the other networks, right? How do they send the packet to the specified host, since the local and the global address is the same, the destination
For which one?
address?
The IPv4,
Yeah.
Yeah. So what other networks see, right, is the IP global. Okay, the IP global. That is so whether you have only one or you have several in the pool, whatever is assigned to you will be mapped in your NetLab, right? But that IP global address is what other hosts in the internet see. They don't see the local private address, the IP local, right? So when they reply, they will reply to that particular IP global. And NAT already mapped. For this IP global, it's actually mapped to this IP local, right?
Oh,
So what happened is the NAT will actually go into the packet. The sender part, the sender IP address, NAT will physically replace that IP local with IP global. Physically, go inside there, up to the network layer, look at the source, take the source IP local address, make the entry. Okay, this IP local address map with this IP global address, and then substitute the IP local address as a source IP address with the IP global address. So when it's forwarded into the internet, and when it reach destination, they see that they see the source is IP global. You know, the intended destination will see the source is IP global. So when they want to reply, they take the IP global from the source, put into destination. Right? So it will, because the destination is IP global, it will reach the R2, for example, the router. So the router, when you look at destination, it wants to know for this IP global destination, which host inside my private network should I forward it? So it takes that, check through its entry, net entry. Because there's a mapping just now, IP local, IP global. So it checks the IP global, it's fine, and then it finds the mapping, which is IP local. Then it will replace back the IP global with the IP local. Since it knows the IP local already, it will send it to the IP local inside the private network. So that's what the NAT will do. And yeah, the outside on the internet, they see the IP global. In the case that you want to use port, they see the same IP global, but with a different port. The mapping is using additional port for the PAT. Whereas for the NAT without the port, it is actually physically an available IP global address. You will have a pool of them, okay, to be used. So each local IP local address will be mapped to a unique IP global, and that is an entry inside the NAT.
okay.
So, okay, Noel?
Okay, thank you, sir.
Yeah, it's okay. Any other question?
No.
How about you, Farah?
No.
Okay. Kevin? Kevin, okay?
The workbook questions. I'm not sure.
Which one to do?
Yeah.
Okay, so don't look at the workbook first. You look at the tutorial that I shared. The tutorial has a page number and which one you should do. So that means if it's page number, then you have a list, then you have to do the list. So let me see. Let me just go to the tutorial 4. Now you can see that I just share the screen now, so you can see also. Okay, so right, the workbook is here. Right, open that. So, like I said, Farah punya kan referred to is a workbook page 5. So, we have to look at the page 5 down here. Right? 3, 4, 5, 5. So, Farah will do all this. right? So let's say Kelvin lah, Kelvin. Okay, page 18. So look for page 18. In fact, if you have the time, you can also attempt the other question in the workbook, right? When you have time. But for now, you may just do what you are assigned. Page 18, right? So it says page 18, right? So page 18, you do page 18. This one, 4 to 10. If you want to continue, fine. It's okay with me, right? But if page 18, then finish page 18, then it's okay. Is that okay, Kelvin?
Oh, okay. I try.
Yeah.
Okay.
All right. So once you actually know how to do, and quite fast also, right? See, it says list the range of source addresses for each ACE, access control N3. Example here, access list 10 permit, right? So that means you need to understand 000 means what? The mask here, the wildcard mask, right? That means it must match, right? Must match. One is the don't care. 0 is must match. So the only possible, because you're given 150, 50, then all 0, then no choice. Means only this particular address, right? So if it says any, what does it mean? So any address. So for example, this one, the mask is 63, right? 63. So if you see this 000, the first three must match. So 195, 223, 50. The first three octet must match. So now the range between 0 to 63. So if you look at it, 1 is don't care, 0 is must. If you look at it in binary, you'll find that the range is between 0 to 63. Right? So the same thing here. If you look at this, it says deny, but you want to see the range. So 000 here means 210, 10, 10 must. So you have to put 210, 10, 10, 10, 10, dot, and then what's the range? 255 means any, right? 1111 means any. So 0 to, so that means one branch address. So 0 to 255 lah. Because the fourth octet any will do. You can see 255 is all one. It means any will match. So 0, 1, 2, 3, all the way to 255 will match. Is that okay, Kelvin? So you answer like that lah. You provide. Yeah. So it's quite fast actually to do, even though quite a lot. So if you want to do more, is by all means. Okay, it's like a practice. Yeah.
Okay.
Right. Because once you get to know this, to do this quite fast, when you are given this situation later, it becomes easier for you to recall back. Definitely ACL will come up in SBA, I can tell you, right? And I have to check for the test, the written test, whether ACL is part of it. Probably up to, I'm not sure, I have to check ACL is part of the test or not. But exam, definitely lah. SBA also. Right? Any other question?
No.
Kelvin?
No.
No, okay. So yeah, just please proceed to do your tutorial. Okay. Also Farah, proceed. come and mark it.
Sir, I need to do all 22 questions for the not just until 10.
Is it this one you're talking about, Kelvin?
Yeah, the page 18 until question 10, but it's still longer.
Page 18 until 10. That's fine, right? If you want to continue until end 22, for example, you're more than welcome. But until 10 is okay.
I also not sure my answers are correct or not.
Okay, I will go through and correct it. Don't worry. Yeah.
Okay.
Mm.
So the other one, is it page 20 or 21?
Hello, Kevin. Which one, Kevin? 20?
The page 20, is it page 20 or 21? You want the other one?
This one, 20. Let's see. Yeah, it should be the 21.
Oh, okay.
Yeah, because this one is the instructions, I guess. Yeah,
Is it
21.
the same thing?
Yeah, I think so.
Same kind of question.
But this one is source address, huh?
Okay. All range.
Yeah, range.
Can there be like two ranges, like one range and then the other?
Yeah, the range could be one to many, depending on the access list lah.
Okay.
Hello guys. I'm so sorry. It's already 4:20, yeah. I think we've gone over our pre-allocated time, and I hope you guys don't mind lah. Huh?
Okay,
24 minutes.
can check answer.
Can I go check your answer? Sorry about that. If you want to leave, can already. Can leave.
I leave after you check the answer.
Can. No worries.
Sir, I leave first, first.
Okay, can.
Okay, sir. Thank you.
Thank you. All right. So for Kelvin, let me see Kelvin. I correct Kelvin punya first lah. Start C. Okay. Let me just check. Page 18, right? Okay, let's check on. Okay, so this one, then okay. So all right. So let me just double check this one. Just one I mentioned to you. Page 18, page 18. Yeah, this one. Uh, so apparently the source address one is actually just um the valid host addresses. Yeah. So can you? I know you because I just now I mentioned 0 to 255. So can you adjust, Kelvin? Just the range, the host address range only, right? Can you change that?
Oh,
Yeah, sorry about that. So I thought this was the whole address range, but only for the host.
only for the host, so it's just
Yeah, so that means this would be 1, this would be 254. Can you
oh,
adjust? Yeah.
so still a
It's,
range, but
the range is correct, but just the host addresses.
oh,
Yeah,
host
correct.
addresses must be like this.
So can you change all of it to be host addresses only?
All of them, not some
Mm-mm.
of them not host address.
I mean those that relevant lah. So like
Okay.
this correct already. This one host address
Oh, number 5. Number
number.
5 is not host address. You didn't say host address one.
Yeah, host address. So that means network address and broadcast not included lah.
Oh, so all of them need to change it.
Yeah, all of them.
Oh, okay. Then why is it in the example there? That one is can do from 0 to 63. That one.
Yeah, so that's why I thought so. But the answer given for me to check is host address only. Yeah.
Oh, okay.
Oh, does it says
That the example is just TCP host fragment. Not sure.
I see. Hang on, let me just check. Maybe. Wait. Hmm. Sure. Let me double check. Maybe I'm looking at a different one. But your range is correct already. So just hang on now. Maybe no need. Yeah. No need. Sorry. I give you wrong answer, wrong information. Can you revert back? That's correct already.
Oh, okay.
Yeah, different version. Sorry, can you revert back? Okay, thank you. Okay, so version 2. This one access 1, 2, and then there's 2. All right. Can you just check? That's correct. Here is correct. This one should cover this one. 7, 15, 0, 255, correct. This one 172, 10, 0, 255, correct. Any address, correct. 1720 to 127, correct. And then 550, 10 to, yeah. Okay. And let's see this one, page 20. Number 4. 4, 192, 110, 208. Is it number 4, number 3? This one, right? Number 3, Bhavan. Start from number 3, is it?
Oh yeah. Oopsie. my
Okay.
numbering all wrong.
Okay. Sorry. So you just changed the numbering and then check here this part. 192.208 to 223. That's correct. Then 210, 1792, correct. 72223, correct. 184 to 191, correct.
Maybe I missed one.
264 0. Okay. 280 to 143.225, correct. 160 to 9, correct. Number 8 to 80. Number 8. Number 8, 117. Hang on. Number 8. 172. Number 8 is 172.16 to 8. Your answer.
Did I think I might have missed one question. Yeah, I missed number 8.
Okay.
I think I skipped number 8. Oopsie.
Okay.
I skipped number 8. Just directly 9. This one is 9, 10, 11.
This is 9, right? So just put 9 here.
Yeah.
Then I might correct this one. 1 and 2, 1, 6, 8, 1, 2, 6. Yeah, correct. Yeah. 2, 3, 9. That's correct. Just change it to number 9 like that. So that we don't. And number 10, 6, 0. 19 to 191 to 55, yeah. 172 10, yeah. 11 10 64 0 to 255. And how about this one? Oh yeah, 000, right? Oh yes. Okay. All right.
The concept. Okay. I
Okay.
think.
Yeah. 7, 8, 1.
For the number 5, right?
Two. Did you change it? Did you add in?
Yeah, add in the 8.
Oh. Okay, number 8 is 1280 17269. Okay, correct. Yeah, so sorry, Noel.
For number 5, right, on Kelvin's question.
Number five. This one?
Isn't the 192.6 default is the destination address?
Number
Because the
5
question,
now. 192.168.5184 to 192.168.5191, and this one 194. Sorry, Noel, what are you talking about?
the question asks for the source address only, right? But isn't the 192.64 is the destination address?
Oh yeah, Ken. Yeah, source address only. Correct. You're right. So that means the no need actually to provide this one because you only want the source. So that means all the one with the source you can ignore. So that means this one. Correct. You're right. I just check. Yeah. So this one no need. Anything with the source. Sorry, the source only. So yeah, the destination on it, since the question specifically say that. Yeah, so the last one, 11 also no need this one.
Okay.
Since says source only. Okay. Thank you, Noel. Yeah, for catching that one. Yeah. Okay. So right, so Noel will continue the rest. So, okay. Let me just go back here. Let me check Paris punya. So the 3 router router A, router router A. This one correct. Number 5 router B, router E. This one router C. No, this one is 01. F 01. Seven to C 1 8 to A. Router E. C 1 router E. 00 F 51. Page 17 for Novel. That's correct. 0 to 5, 0 to 5. 0.031, 63. Two is page 9. So router A. Right. Good. C. C. D. E. Again is from the E. And router C. Page 42, 43. Then 5 to 6. Choose this. Okay, 5, 6 is this one. So what's the problem number 5, huh? Is it this one? No.
The question also got typos.
40. 43, 40. This one, yeah?
Yeah, that one.
Okay,
On
what typo is that, huh?
On router B, right, there are two interface, same interface, which is S001. There are two of them.
Yeah, you're right. How is that possible again? Okay, so okay, it's include. So press the access keys at router name interface. You put it at A. Is it A? Oh, sorry. Where'd you put it? B. B. This is extended. So commit network 204.95, the same packets to 800, but not to 210. Not here, but to 172.900. So this part now, but not there. This part, but not there. Permit other for output now. Okay, so you're putting it at B, right?
Yeah.
So extended access this. What is the guideline?
Based on the source, right?
Based on the source. So from here. So if closest to the source should be router A, not B, kan?
Yeah.
Right. So you should try put router A lah.
Oh.
Yeah. Can you try for router A instead? So closest to the source router A, FA000, right? When here,
Oh.
yeah. So all right. So maybe you can adjust your answer. Okay. And I'll check it again later. Same as number 6. Number 6. Place the problem number 6. Place the access list at. So number 6.
Oh, that one in
Router B. So router B to receive an information from. Let's see. No, this one. Six. Right in the extended access list. This one extended. No, extended also extended to allow Rachel's computer at 204 to receive. So receive. So that means coming from 172. So closest to the source will be router B, correct? So closest to the source will be FA1 at router B. If the traffic is coming from here, extended list closest to the source will be this one, router B FA1. Router B should be FA1. Right? Noel?
Okay.
Yeah, router B FA1 because extended list coming from this 172.59 over this side lah. Means access list should be there. Closest to the source. The source is here, so router B at this interface FA01. All right. Okay, so I'll let you look at that also. Change here also. Okay. So okay. So please continue first. All right. So let me see this one. The A 0. Access list 150 and 151. Access list number 100 to 199. To the access list not science lab.
Oh, that one I just name by myself.
Oh, okay, okay. Router B. Deny IP 204.95.150. Okay. Um, why do you have two access list?
Oh, this one only.
I think one is enough, right? That means you can combine the requirement for 204 permit 204 and deny that means 204.150, 00255. Deny 210. You're permitting this one, right? Denying. Should be denying. Deny not to the 210.20.250.10. 250.10. What? So that means you should deny this one, right? You should deny 210, but to permit 204. You permit this, but deny this 210, right?
Yeah.
Yeah. I mean, this one is permit, not to means deny this one. Deny permit to packet to send packets to here, but deny deny is a permit to send to this, but deny to this. That means you block here. That means you filter out this one, right? So you permit. That means you permit. That means if you allow to 172 means you permit this one. Permit to go out, but not to the 210. Right? So you deny.
Oh, I need to put the source again, right?
Deny this part. 210. I mean, yeah. Okay, so you work on that first. And then number 6. Prompted. You don't need to separate the access list, huh? You can just use one access list and then use it for the whole access list here.
Oh, okay.
Yeah, no need to separate them. So all right. All right, so I'll let you work on that first, Noel. Then I allow I let you guys complete the rest first before I. Okay.
Okay.
Okay, Kelvin. See you. Right, Noel, you do first. Both your answer you can combine the yeah, like this, combine the access list number into one, and you can just do the access list to satisfy the requirement. All right, lah. Noel, I think we'll stop here first. Okay, you can continue first on your own. Is that okay?
Okay.
All right. Thank you. I'll see you tomorrow.
Thank you, sir.
All right. Well.